Understanding the Kutta condition. Flow leaves the trailing edge smoothly, velocity is finite. We are interested to know this finite velocity is same or it is different. And to understand that, we have a study which shows there are two methods to study our airfoil. The first method is the pressure method and the second is the slope method. First method, the pressure method says that this is my trailing edge point A. This has a single pressure. Pressure is same, so velocity has to be same and cannot have two types of velocities at A. Second, the slope method. At A, we cannot have two slopes, suggesting two different directions of velocity is not possible. If my V1 is different and V2 is different, that is V1 is not equal to V2, this shows physically this phenomena is not possible. So, two different velocities at point A is not possible. One point to remember is flow is turning around a sharp corner. Flow has a finite velocity at corner for potential flow. For a potential flow, if my flow is turning around a sharp corner, it will have a finite velocity. Let's understand, if my V1 and V2 are not same, then what is happening? If my V1 and V2 is not same, then any one will be high, any one will be low. And according to that, the flow will be happening from high potential to low potential. Let's consider this trailing edge section. This is my trailing edge, and here my V1 is zone of low pressure and V2 is the zone of high pressure. So the flow will be turning from zone of high pressure to the zone of low pressure. It's turning. So the flow is turning around a sharp corner. This is not satisfying the Kutta condition, because in Kutta condition, the flow has to leave the trailing edge smoothly. But here, the flow is not leaving the trailing edge smoothly, rather it is turning around the trailing edge. So, we should be understanding some cases for the trailing edges. Now we have 4 cases to understand. Case 1, Case 2, Case 3, Case 4. In all the 4 cases, my airfoil remains the same. Only the difference is with the stagnation point. The stagnation point are moving closer to my trailing edge and then moving far away. In this, my stagnation point is located very far from the trailing edge, is located a bit closer to the trailing edge, located at the trailing edge, and again here located far away from the trailing edge. In this condition, when my stagnation point is very far away from the trailing edge, lift production is very hard because there is no circulation. The second condition, we have a low circulation. The third condition, when my stagnation point is at the trailing edge, that time circulation is satisfying the Kutta condition, that is, flow should leave the trailing edge smoothly and tangentially. This has been satisfied in this condition, in this case. And in fourth again, we have a high circulation. So this circulation, this has been picked by the nature. A point to be noted, at the trailing edge, only one velocity, static pressure, is possible. This too can be linked by the Bernoulli's equation. We usually prefer to say velocity instead of static pressure. Now, flow should leave the trailing edge smoothly and tangentially. This is the key point of Kutta condition. If we have this kind of trailing edge, this is not possible because at this point my velocities will be intersecting and V1 and V2 different velocities, it's not possible. In this condition, if my V1 and V2 are equal, if V1 is not equal to V2, then flow will start curling up or downwards. If V1 is equal to V2, this is the condition and it's okay. But if my V1 is not equal to V2, then this will be the condition and flow will start to curl upward or downward depending on the zone of high pressure and low pressure. Now, some key points to remember is that this principle, this condition of 4 airfoil, this is a principle that describes that air flow around the trailing edge of an airfoil. It states that for an airfoil with sharp trailing edge, the air flow must leave the trailing edge smoothly and tangentially. This condition ensures that the flow does not experience sudden change in velocity, which would be physically unrealistic.